Very good afternoon to all of you who are present over here. I extend a warm welcome to everyone today at this NDDB Samvad session. My name is Sunit Gautam and I serve as a Deputy Manager in the NDDB Cooperative Training Group. We are honored to have with us Sri Sunil Sinha, a Senior General Manager from NDDB Engineering Service Group. He is the Department Head of NDDB Engineering Service Group. And additionally, we also have Sri Alak Kulkarni, Manager from Engineering Service Group, who had joined for this session. So today, Sri Alak Kulkarni will enlighten us on topic New Generation Dairy Plant and Operation Efficiency. I open to Sri Alak Kulkarni to share his insight and address the participant.
So good afternoon to everyone available here. And I am Sunil Sinha, as my colleague Mr. Sunil Gautam told you. My colleague Mr. Alak will be presenting you the next generation dairy plant and operational efficiencies. You are welcome there. Thank you very much. Have a nice session.
Namaste and very warm good afternoon to one and all present over here. We will start with our session, that is topic for today's discussion, which is next generation dairy plant or a new age dairy plant, we call it as, and then operational efficiencies. So in this session, we will touch upon basically the four aspects of this topic. First would be the next generation dairy plant. What is this concept exactly? What is meant by next generation dairy plant? It's basic, some fundamentals. And then of course, we will touch upon the automation aspect, because when we talk about the next generation or new age dairy plant, we must have the automation in place, which is the key factor in next generation dairy plants. And then another solutions, renewable energy solution as a sustainability aspect in this new age dairy plants, that is also an inevitable part of this next age dairy plants. And third aspect would be the green building concept. It's a little bit new concept in dairy industry. It's anyway in implementation, various other industries and everywhere. So here we would talk about all these four things, and further we will have some discussion about the efficiencies of the dairy plant, operational efficiencies and other things. So how can we go for a new age dairy plant and energy efficient model?
So I will just intervene with your kind permission. You know, we also need to know from where we started. The dairy industry started long back in our Indian culture. In this Bharat, what we say, the milk business has been going on for eons together, and there were small automated dairies before a cooperative movement was started way back in 1948, 46 in the form of Amul in a small village. And there were first generation dairies which were fully, they were basically a manual dairies. Where everything was done, the walls were opened manually, even the transfer used to take manually, even the dumping of the milk into the into the collection tanks. Okay, so this all developed, and we had Operation Flood 1, 2 and 3, and finally the fourth generation dairy plants, what we see, they are mostly automated, fully automated. The purpose of automation, why we have gone through this, will take up during the course of discussion. And if there are any questions from you on this, we would invite to you, because it should be a two-way communication. Thank you. Yes, sir.
Thank you, sir. So if we see the project trends, just rightly explained by Sinha sir, that during the operational flood phase 1, 2 and 3, which ran from say 1965 up to 1998, thanks to Dr. Verghese Kurian, a visionary leadership there. And after 1998 till date, we know that India is the #1 milk producer in globally. And after that, there was a perspective plan. So if we see that, how was the project trends which NDDB executed? So during this operation flood time and during the perspective plan time, the dairy plants were, people were interested to go for this 50 TLPD, 50,000 liters per day to, let us say, 5 LLPD dairy plants. But nowadays, in last 5 years, it has been drastically increased. 5 LLPD plants are starting from the 5 LLPD, and it is going beyond the 15 LLPD nowadays. If we see the powder plant, it's up to 30 TPD, and nowadays 120 TPD, even more than that, about 150 TPD we are talking about, and we are recently executing one of such projects right now. And through the point of view of these operations, so previously it was either manual or let us say semi-automated or semi-mechanized way to reduce the human efforts. That was the basic key. But nowadays people are demanding, everybody is demanding that fully automated dairy plant should be there in place because of the lot of benefits of the automation to tap. So if we talk about the cattle feed plants, so previously it was around 100 TPD. Nowadays those are it has crossed the 1000 TPD also. There was one good project of Khattarwa cattle feed plant. Previously, the thirst area was just milk or conventional products, butter, ghee, and fermented products, or some ice cream or milk product. Nowadays, we are talking about cheese, we are talking about whey powder, we are talking about indigenous sweets. So value-added products are given more stress these days. So there are some special projects also that BSL Biosec Lab and Solar and so many things which are actually complementing the dairy industry in the view of some animal vaccines and so many other things. So this was the project trend we are looking at. So why should we go for next generation dairy plant? The basic fundamental question. The first and foremost, the good key for this is the large number of dairy plants which were established during this operation flood time. During the 70s or 80s, those were established based upon the technologies available contemporary to that era. And basically those were either manually operated or let us say some semi-mechanized or semi-automated type of things. So during the due course of what you can say the expansion of these plants, so somewhere in some of the plants some modern technologies were adopted as a time and when they just expanded this plant, but many of the plants are still in a manual condition. So the basic need is to what you can say refurbish or take these plants to next generation dairy plants for tapping the environmental sustainability aspects, the automation aspects, and so many other things. Another thing is today's this world is that if you talk about the today's market, then it's competition is huge competition. So if we need to sustain into this competition, then we need to have some efficient models or efficient plants in place. Changing consumer preferences, then people are talking about what add-on you can give it to us. Just if fine, we are eating the curd or we are eating the yogurt, but is there something add-on present into it? Are there some functional foods added? Are there some what you can say good for my gut? So something you are doing for that. Since such value-added products are actually people are consuming and those are in interest. So are our dairy plants are catering to these needs or not? That also needs to be taken care. So next generation dairy plant. Then rising prices of raw material and energy. As day passes, then energy consumption will be there, and for this consumed energy we need to give more and more prices day by day. So we need to restrict ourselves, or we need to limit ourselves regarding the energy consumption inside the dairy plant per unit produce. The efficiency, increase in efficiency. So if we can say the four key factors to remain the competitive in the business, the first is entire life cycle of the dairy plant, how I can cut down the cost or how can I optimize the cost of the operation in the plant. Then improved flexibility during the changeover of the products, changeover of the producers, where actually when I change over from one product to another, then there can be CIP, there can be cleaning and so many other parameters or processes. The steps of the process will come into picture, and whether are those efficient enough. So that needs to be taken care. Then consistently the high level of quality should be maintained, because nowadays market is very much quality conscious. So and there should be the consistency in every batch. We should have consistent quality. So highest possible efficiency, we need to go for a dairy plant. In next way, if you talk about the new age dairy plant or new generation dairy plant, then this concept revolves around state of the art installation of the plant, whether the dairy plant which we are going to install is as per the latest technologies, the state of the art, whatever is the latest is there, it is as per those technologies or not, or we are again installing something way back behind to compromise somewhere in our capex. So that could be the one time good saving, but throughout the life cycle of this plant, its operational efficiencies and all other things that produce. So whether is it really going to be beneficial or not, that needs to be assessed in very well. Then strict hygiene and food safety is a fundamental thing. Food safety, everybody is talking about now, the food safe plant design and operations, and hygiene is to be maintained. So that should be the key factor in our new dairy plant. Next, consistent quality. If quality is not consistent enough, then consumer will not definitely prefer your product. So if consistent quality should be there, then our plants and processes should be a thorough with minimal manual interventions into it. When there are a lot of manual interventions, or the recipes are dependent upon the what you can say, the manually driven, and which are not automated enough, then at that time there are chances that batch wise there will be some difference into the quality, or what you can say, the product consistency, consistent quality. So those may not be preferred by consumers. So we should have a next gen dairy plant, and there should be some automation technologies available. Efficient resource planning, the key factor, because the resources used per unit product is the key factor to analyze how efficient my dairy plant is. Then advanced technology and automation, of course, the integral part of a next generation dairy, and which are the sustainability aspects in my dairy plant. Those should be assessed very well, and those should be an unavoidable part of a next generation dairy. So let us talk about the first portion, that is the dairy plant automation. So if we see that in this the whole domain of the automation, there were three eras. The previously in 90s or early 20s, we can say the focus area was the mechanization. So the main purpose was to reduce the human efforts first, and afterwards it just shifted towards the automatization of the processes. And it was in last few decades of 20th century when this electronic development just kept on, and which came to, of course, our dairy industry also. So how can we automate? So there are benefits. That system executes the tasks and has a decision taking ability, while human interference is very much limited into the system. So today we are talking about the cybernation, industry 4.0, and of course what you can see, the IoT, the Internet of Things, where all data of my plant is available on my fingertips, so that decision making for our management, that what is the condition of this plant, is it really working in an efficient way or not, or there should be some improvements to be done into this processing plant. All this data should be available on just some clicks. So, and everything should be connected with each other. So these are the age of IoT. So this cybernation era today we are living, and our dairy industry is not exception for that. we need to go for that. And why to automate a dairy plant? Just two pictures are there. This top corner picture, and there is a right side bottom one. You can just, looking at those pictures, you can just which plant would be the automated plant. There is the no water or no product on the floor. The neat and clean and hygienic design, cleanability is maintained. And the downside, you can see a very you can say a shabby look of manually operated dairy plant, because in the due course of manual operation it happens. Another good picture, if it is an automated dairy plant, no product or no water on a clean floors, those are clean floors, and there is some good design. You can see white colored milk is poured everywhere, because finally this is a manual. If something goes beyond our control, if power cutoffs are there, then manually some has to go, and the back releasing wall has to be shut off, and if there is a delay in manual plants, then such things could happen. So to avoid all such things, such losses, this automation is the must. So why to automate a dairy plant while going to a new generation dairy plant? The first and foremost thing is, in a manual dairy plant, or if such dairy plants where manual operations are very prominent, then such batches are dependent upon the skill and judgment of the operator, leading to the concerns like non-uniform product quality. Of course, batch to batch it may change, it may vary. Of course, there are skilled people, but still, when there are manual interventions, the processes are not automated, then this can happen. Plant hygiene, more and more human interventions, means there could be the hygienic constraints if SOPs are not followed in a very perfect manner. Then high consumption of energy and services. Of course, manually, if I need to manage or stabilize the plant, or have some energy consumption and logging and everything, and there can be chances of errors, and what you can say, the optimization can be very limited in such plants. Then extensive requirement of skilled labor, of course, is the need of manual dairy plant. And plant data and report generation. In automated dairy plants, all this data would be available on fingertips as a MIS, management information system. But manual dairy plants, it's very difficult to manage. There we need to manage the logbooks and everything, and chances of manipulation also may be there. Traceability and troubleshooting. The most important factor is traceability. In today's day, the people are asking, if we want to go for export, then the traceability should be there, and as much possible to the grassroots level. Today we are asking about the traceability up to the dairy farm level. So our plant is in between. We are in between the cow to consumer. We are bridging these two. So traceability and troubleshooting for every batch, for every pasteurization, for every UST, for every powder, everywhere is very much important. If something goes wrong when my product is in market, then I must have everything logged in a very efficient way and this can be done only in automated dairy plant in a very efficient. So it's a key now. See, then automation is a key for next generation dairy plant. First, production cost reduces. Of course, yes. Then flexibility to meet market demands during summer season, during winter season. We can see there is a rise of ice cream or charge in during the summer season. At the same time, in winter, it just goes down. Or some products and some if we have some if we need some flexibility for this market products in automated dairy plants, it's very easy to manage. Then next thing is adaptation to changing statutory demands. If there are some statutory demands, changing statutory demands, for example, let us say all we know this, it's a very simple pasteurization hour. So previously the marker bacteria for this pasteurization was that pathogen was this tuberculosis bacteria. And nowadays we can see this your bacteria is coming into picture as a pathogen. So in this way, if some legal demand is changing, if something is there, previously it was some 72 degrees Celsius for some few seconds, and now if something is going to change in manual dairy plants, change it manually, then stabilize the plant, then validate that changes, and again take the production. It is a cumbersome and also time consuming. In automated dairy plants, over a few clicks on console operator station, by changing just set points within the designed limits, it is possible. So adaptation to changing statutory demand, increased productivity. Of course, efficient production is there, and resource utilization or utility services utilization optimized. So efficiency of my plant is a good improved, and so that I will get an increased productivity. And of course, reduced losses, rinse milk collection system, or this what you can say the TS recovery during this water push and product push. All this will be implemented in this next generation automated dairy plant, so we will have some reduced TS losses, and of course the energy losses. Guarantee the safe operation and hygiene, and of course the manpower saving. When we go for this automated dairy plants, there are always hue and cries that job chale jayenge logon ke, but it's not actually the case. Automation has its own type of requirements. A skill development happens there to maintain some automated walls, to maintain some PLC-based control systems, SCADA-based control systems. So we need to actually train these people, so their knowledge base also get elevated. And further, if for unskilled levels are, they can be used for other operations, other good operations into the dairy plant. That resource can be diverted over there. So again, efficient production, planning, execution, and reporting. Reporting means data logging can happen into this next generation automated dairy plants. So if you automate a dairy plant, your existing brownfield as a brownfield project, or if you have some greenfield and automation dairy plant, so what are these immediate visible effects of this automation? Most of us have seen that top left side corner, that paper based chart. Actually this was for the traceability of every pasteurization batch. This needs to be maintained, what was the temperature, this holding coil, and all those things. So today everything can be maintained in the SCADA based system. You can just see the good smiles over there on the operator's face over here. So control the milk production losses. It has been observed that if we implement this automated dairy plant, the rinse milk collection system and everything, so almost the losses about just 0.6%, we can just bring it down. And then ensures food safety and consistent quality, efficiencies increases, manual intervention reduces, so that this can be achieved. Next, improved plant efficiency. If we talk about the water consumption, then in automated dairy plants, contemporary to manual dairy plants, where it's more than one or more than around it's touching to 2, 1:2 ratio for milk production to water consumption. In automated dairy plants, it has come down to 0.7 to 8. We have observed more lesser than this if it is just liquid milk processing. If there are more products, of course, plant to plant, this can vary, but it's definitely less than 1:1. Daily MIS reports. These reports are actually, this enables our dairy plant management to take decisions about what is the health of my plant, whether how is the production, whether it is efficient or not, and which should be the opportunities and improvement areas. And there could be the manpower saving. Some data is presented in this slide. You can just refer it. The next aspect is a new age dairy plant. Then we must go for some renewable energy solutions in our dairy plants. today everybody is talking about the climate change. It's as a man-made disaster, and there is a need, an immediate need of course correction for that. Everybody, we can just see there are floods right now. Also in Japan, people are suffering from that. There is tsunami and earthquakes and everything. So all these things, all these adverse things are nowadays attributed to global warming and climate change. Dairy industry being a production industry, we are not also the exception for this. So we need to have some good solution as a renewable energy solution in our dairy plants, and this should be like an integrated approach in the plant itself. Many of us might be aware that there was a COP26 Glasgow summit in 2021. It happened, and it's called as Glasgow Climate Pact. So almost 195, 197 countries signed this. We also signed. So what are our commitments? It has been given by our Prime Minister. It's from his speech. You can just refer this speech. Speech is available on the website there, the ministry's website. But the fantastic thing is, it's our commitment to global dairy or global fraternity, that how we are going to achieve the carbon neutrality. So we say that it's Panchamrit commitment. So there are 5 elements into it. So first is increasing non-fossil energy capacity by 500 gigawatt by 2030. The next and very most important is by 2030, the 50% of energy requirement, means 50% of energy requirement of our country, that we are committing that it will be from renewable energy by 2030. So we are not exception. Our dairy plant should have something integrated into it where we use the renewable energy. Either that can be solar, or we'll just discuss those in next some slides, which are implementable solutions. Then reduction in total carbon emissions by 1 billion tons in 2030. And also India will reduce carbon intensity to its economy more than 45%, and by 2070 our country will be the carbon neutral, means net zero we will achieve by 2070. Means whatever the CO2, being a greenhouse gas, it contributes to the global warming. So whatever CO2 we are emitting into the atmosphere, that we will take it back. Taking it back is called as sequestration. So there is a carbon sequestration percentage, 100% we will achieve, that our emission and our sequestration, this ratio will match by 2070. So we have committed to the global community. So being in dairy sector, we should comply to this. So which are some solutions? So before going to the solution, just few slides, the few data if you want to refer. There is a huge potential of this solar energy, and India being a tropical country, we have availability of solar throughout the year. So per capita consumption, if you can see in the slides, India, it's just 1.7 CO2 emission per capita. CO2 emission per capita, it's ton per year. So, and some Middle East, it's going around 19.5. It's about reaching to the 20. It's per capita emission, tons per year. It's in year, tons per year emission. So there are some values. Again, the people say that population itself is high in India. So when you divide it, the total emission, then this per capita emission goes down. So some arguments always would be there. But we should have the conclusion is we should have something in our dairy plant which attributes to this non-renewable energy sources. So if you see the solar map of India, so a very good throughout the country, the very good solar radiation, which is called a GSI, is available. So which could be the possible solar solutions, interventions when we talk about our next generation dairy plant and its sustainability aspect? So there are 3 to 4 things which we have identified and also implemented. The first thing is concentrated solar thermal system. It generates the hot water about 80 degrees Celsius, and it can also generate the steam also, but we have implemented the hot water generation system, because in dairy plants, hot water, need of the hot water is very prominent. It's for cleaning, for crate washer, for CIPs, everywhere this hot water is required. So these days the trend is, it's a typical industry trend that we generate the steam, we heat it using the fuel into the boiler, again we use the steam to heat the water. So again, it's this round approach. So we thought of, in our dairy plant, mostly we get the vacant terrace area. So can we implement some solar thermal system which can give us the hot water about 80 degrees, which can cater the need of the dairy industry. And the fantastic, this solution was very fantastic, and there are some implementations which we'll be discussing next slide. Next is rooftop solar PV. It generates the electricity, solar photovoltaic PV means, and its maintenance is, you can say, very less as compared to this concentrated solar thermal system, and it just keep on generating the electricity which can be utilized into the plant, which can be fed back to the grid, so we can get some compensation into the bill. The third one is village level solar thermal storage system, TSS we call it as. So in remote locations where electricity cutoff is very prominent, so there whenever the availability of solar radiation, then it works like as a smaller, you can say, ice bank tank. So it generates the chilled water, it stores it there, and it can be utilized to chill the milk. So quality is improved, and it's very a good, you can say, approach where we have some DCSs in remote locations. Then rooftop hot water solar generation system, if there are some domestic buildings like administration building and something in dairy plants, so these things can be used. So if we see the typical thermal energy usage in the dairy, so we can just have a look that can washing, crate washing, as just we discussed now, then CIP, and to feed the boiler makeup water tank, and everywhere the hot water is required. So amongst total usage of dairy, it comprises 65%. So just 5% goes in UST, and making sweet some 10%, and milk powder up to, it can go up to 20%. It's a typical data. It may change as per the configuration of plant, but typically these are the values which we have observed. So our area of interest is that to how can we tap that 65% hot water from the solar. So available these solar concentrated solar thermal technologies till date, these are the good and available technologies. One is called as compound parabolic concentrator, that is CPC. Another one is, this is non-tracking type, paraboloid dish, and there is parabolic trough. Dish and trough, these are tracking type of technologies, so they can track the movement of the sun, so that we can get the more and more output. CPC, that first one, is non-tracking type, but maintenance is less. If tracking type is there, then there would be some motors to revolve this complete system towards the sun, so there could be some maintenance aspect coming into the picture. We have installed both these things, CPC is there and tracking type of thing is also there. So if we see the typical CST process flow, how it happens, then there is a primary circuit, there is a PHE, which is plate heat exchanger. So in the solar field actually captures the solar radiation, and it transforms, heat is getting exchanged into this plate heat exchanger. There is a circulation of water, and basically this water is a RO water to extend the life of the solar field panels. And this heat is exchanged into this plate heat exchanger to the secondary circuit, and in secondary circuit there are thermal storage tanks. So continuously the water will be in circulation till we get the desired temperature. And again, the same pumps, which are recirculation pumps, can feed this water when temperature is reached to the boiler makeup tank or crate washer or in CIP systems. So till date, NDDB has implemented various CST projects. So in Maharashtra, there are 6, in Punjab 3, Gujarat 1, Karnataka 5. Another one is in Karnataka, Udupi, Uppur Dairy, and Maharashtra in Wamul, and Samvad Dairy. So if you see the paybacks, these are calculated when as per the year of installation, nearly about in 2017 and afterwards. So if it is FO based boiler, then you can get the savings of around this payback. Paybacks are very interesting and attractive, 4 to 5 years the payback. If there is a briquette fired boiler or maybe coal fired boiler, when the fuel cost is down, then at that time it's slightly more. Previously, there used to be MNRE and UNDP subsidies available, Ministry of New and Renewable Energy. There was a subsidy available for this, and subsidy was depending upon the wish technology and what is the aperture area. You could see in one of the columns there is an aperture area. Actually, that comprises the what is actually solar potential we are tapping from there. This is in meter square. So previously there used to be subsidies. Nowadays those have been stopped. But you can tap if somewhere in state government policy, if subsidies are available, or in some another scheme if you can implement. So just CST project in Maharashtra, 60 lakh kilocalories per day. This total capacity in some chilling stations and all. There was some CST implementations in such some photographs. And you could see there was some 15-day trial we conducted in one of the chilling centers. So we could observe that 3,000 rupees per day saving can be happened when the boiler was the FO based burner. In Udupi Uppur Dairy, where 14 lakh kilocalorie per day installation was there, you could see the boiler was briquette fired. So around 4,000 rupees per day saving we could observe. And the beauty of this installation was The whole butter melting process was conducted over this sun water, this CST water based process implementation was there. Another technology, this is the solar PV. Previously, it was this solar PV modules, those panels were we used to import those panels, but nowadays that's not the case. And India is now fourth largest solar PV implementation. You can say the deployment in the world right now. It was the data in 2021, but this is actually the what we can say the least maintenance implementation for through the perspective of dairy plants. Though which are the recents in the solar PV. So nowadays footprint of this panel has gone down. So we can have some 650 watt monocrystalline panel or more than that also we can get. So these inverters which can convert this DC coming out of the strings of the panel to the our required AC generation system. Now those are coming with 12 years warranty, or even some in some makes you can get more than that. And there are no bifacial modules also.
I think this is some barrage of information we are giving you on a continuous basis. See, solar PV system, India being so, the sunlight is available so richly to us. We have, you see, look at the technicalities is one part of it. But I can tell you, I'll give you our own example at Mehsana Institute of, Training at Mehsana. Mansingh Institute of Training at Mehsana, we had installed a 60 kVA, 50 kVA plant, okay, solar plant rooftop. Rooftop is preferred basically because land is scarce, and you can have these installations which can give you an added, protection of sunlight onto your to the top floor. So your heat load in that top floor also reduces. अभी इसमें everybody I hope understands Hindi also.
Yeah,
They can, but maybe okay. We'll try. So this panels what we installed, our electricity bill used to be to the extent of 1 lakh rupees per month. 80,000, 1 lakh, 1 lakh 10,000, 20,000. इसको installation के बाद में हमारा electricity bill has taken a drastic reduction. It has come down to something like 36,000, 22,000, 11,000, and the lowest bill was 6,000. Even if I take 1,20,000 to 40,000, there's a saving of roughly 80,000 on an average. Okay? Give or take a couple of these things, you have a tremendous amount of saving. इसी तरह से हमारे पास में जो geysers थे, we installed 3. This cost was 25 lakhs, some 36,000 for solar PV. And we recovered the cost in 4 years. We didn't count the interest and all that. Initial investment is something which you can think of. A lot of residential area people also installing the PV, they are also getting this benefit. They don't have to pay. हालांकि उनको electricity company की तरफ से पैसा नहीं आता है, ठीक है? They don't get that money. पर उनका एक credit जमा हो जाता है. They don't pay anything despite operating not just 2, 3, even 4 ACs. It depends on what capacity of solar PV is installed. Or the beauty of this thing is the life is 25 years. And the life of span of this one where the efficiency will go down up to 80%. तभी आपको 80% तक you are getting the benefit. Suppose you installed a 5 kV or 50 kilowatt, 80% is 40 kilowatt, which is not bad. ठीक है? ये कैसे होता है? एक वो नेट मीटरिंग होती है. जो सोलर का जो भी आपका रेडिएशन जनरेट होता है, whatever your जितना भी आपका जनरेशन होता है, उसका अगर आपका कंजम्पशन से ज्यादा होता है या छुट्टी के दिन पे आप नहीं यूज करते हैं, एनीथिंग लाइक दैट, देन इट गोज बैक टू द ग्रिड और वो दूसरे कंज्यूमर को उससे फायदा होता है. ठीक है? और चूंकि सनलाइट इज अ टोटली ग्रीन एनर्जी, इट डजंट क्रिएट एनी पॉल्यूशन. And if you are utilizing it like this, whether for thermal generation, heating of the water, the temperature which you can go up to is up to almost 80-90 degree. And for that parabolic or concentrator type of solar thermal, you can even generate steam, which is good enough for your process. So these are very important aspect of, and of course जितना आप एनर्जी होम जनरेशन करोगे उतना आपको बाहर से इंपोर्ट नहीं करना पड़ेगा, सो आपका इलेक्ट्रिसिटी बिल ऑटोमेटिकली डाउन हो जाएगा। और हमारा अल्टीमेट पर्पस क्या है, जो इंटेलिजेंट डेयरी का है, जो स्मार्ट डेयरीज ऑटोमेशन या जो कुछ भी है, पर लीटर प्रोसेसिंग कॉस्ट हमको कम करना है, सो दैट वी आर एबल टू गिव मैक्सिमम बेनिफिट टू द फार्मर। ओके, एंड हम अपने लिए भी कुछ रिजर्व जनरेट कर सकें फॉर मॉडर्नाइजेशन, फॉर ऑटोमेशन, फॉर R&D एक्टिविटीज। तो दीज आर सम ऑफ द थिंग्स विच आई थॉट वी शेयर। बाकी टेक्निकलिटी तो बहुत सारी है, सिलिकॉन पैनल कैसी होती है, अभी तो यू नो पॉली वाली आने लग गई हैं। हमने जो पैनल लगाई थी मानसिंग इंस्टीट्यूट में, that was having an efficiency of roughly 19%. Now we have upgraded our specification to 21%. Bi-directional panel आने लग गई हैं, so you have sunlight falling on this side। और दूसरा जो आपको जो स्लैब पे जहाँ पे आपने इसको इंस्टॉल किया है वहाँ पे रिफ्लेक्टिव फिल्म लगा देते हैं व्हाइट कलर की, उससे भी जो लाइट रिफ्लेक्ट आती है वो पैनल की दूसरी साइड पे जो सेल्स हैं उस पे भी वो करती है। सो वी हैव डबल साइडेड पैनल्स आल्सो। बायोगैस भी हम यूज कर रहे हैं, वाराणसी में हमने एक बहुत बड़ा बायोगैस प्लांट लगाया है। 100 metric tons of cow dung we are using every day, and 4,000 cubic meter of raw biogas is generated approximately, जिसमें मीथेन कंटेंट होता है करीब 66%, 64, 66%. So this biogas can be used as a fuel in your boiler, you know, reducing the dependency on conventional आपका जो भी LDO आप यूज करते हो, है ना, जो भी आप ये क्या कहते हैं कोल यूज करते हो, LSHS यूज करते हो, तो all this you know gets reduced और आपका import bill आपसे reduce होता है। You see, so you know the effort has to be सोलर थर्मल का आप टेम्परेचर जो पानी का 90 डिग्री तक यूज कर सकते हो। कंडेंसेट रिटर्न जो आपका है प्लांट में से सब जगह इकट्ठा करके वो आप बॉयलर में डाल सकते हो, प्योरेस्ट फॉर्म ऑफ वाटर। सो यू नो दिस इज गॉट अ मल्टीपल एडवांटेज। अगर आपका 30 डिग्री आप एम्बिएंट टेम्परेचर का पानी लेते हो and then you heat it up to 100 degree, क्योंकि उसी टेम्परेचर पे स्टीम बनती है। Instead of that, if you get a temperature of 80 degree, 90 degree, then your delta T is 10 degree, खाली उतना ही fuel supply करना पड़ेगा। So you have tremendous scope, and this is what we have been doing from the engineering services, consciously working with dairies, working with the end user, industry, and so on. Sorry to me. You please continue further. Thank you.
Thanks, sir, for enlightening us. Further adding to this discussion, technologies are getting advanced day by day. Solar implementations and everything. Previously, people used to say that solar PV model में if there is a large installations over our terrace, then cleaning is the issue and everything. So there are solutions coming up. You can just see over the screen if it is visible. There is a panel which moves over this implemented solar panel, installed solar panel, and there is a what you can say some scrubber or brush is there below that, and this panel, this cleaning panel itself works on the solar because it has the solar panels on its own top. So such solutions are there. There is a diagnostic instrumentation, 2 panels are installed there, and one is kept as it is so that some dust accumulation and everything, let it happen. Another will be cleaned every day. And what is the differential in between these 2 generations? So that would be multiplied with our installations, complete installations. So in that way, when is the cleaning required or my output is going down, everything can be diagnosed. So such advancements are there day by day. So there are some implementations in our frozen cement station Purnia. Some data is available there. So next is the green building concept. So basically the green building concept, the first dairy plant which was erected over this green building concept was in Ajmer by NDDB, and so basically it's like a structure that actually ensures the efficient use of natural resources like building material, water, energy, and other resources with minimal generation of non-degradable waste. So what are the tangible benefits? So if we can see, there is an energy saving of 30 to 40%, depending upon the plant and configuration. These things may change, but there are surely the benefits. Another intangible benefits, if we can say, the the fresh and good daylight, the good ambience, and what you can say, the freshness of air quality, which is very prominent as we are in food sector, food industry. So that can be met with this green building concept. So there are some agencies which give these green building certifications. There is a GRIHA, there is a IGBC, Indian Green Building Council, and a BE, Bureau of Energy Efficiency. So we'll just quickly go through this and not in more detail because we have limited time. So basically on this 6th factor, this green building concept is basically depends upon. So it actually starts from the what you can say, the implementation of project, designing and conceptualizing of the project itself. So site selection, how is the site is getting selected, how is the planning of this all execution activities, then which are the measures used for this water conservation, energy conservation, some material management and material conservation during the erection itself, and of course after the plant when it comes into the operation at that time also. Some indoor environment quality, how it is, and occupational health and safety, how and which are the measures there, and some innovative idea and if implemented into our design itself. So there is a marking, and based on the points which you gain, you will get some certification. Platinum is like global leadership, gold is, this is IGBC green building certification. Depending upon the agency, this what you can say, terminology may change, but assessment happens in this way. We need to get the points, and we need to substantiate that point by point that we have implemented such so many things. So basically a few documentation is required. Some validity of certificate is for 3 years, and this can be, being in the consumer oriented market, so this can be a good what you can say, marketing point that this product coming out of my dairy, and my dairy plant is certified for the green building concept. So the product in your hand is like coming out of a green facility. So site selection, some parameters are there. Actually the basic fundamental is how we can manage our site, how we can manage the resources, natural resources within the site itself during the project execution, that erosion of soil and so many things, and how we can manage that. Something like we have boundary walls, and we have something, what you can say, the erosion is arrested over here during the construction stage itself. So everything should be documented with the photographs and records, so that we can get the good what you can say, the certification. Then water conservation, then some parameters for energy conservation, then material conservation is there, how we can segregate and use these raw materials within the construction itself. Then there is some indoor and environmental quality factors, then some innovation in design. So actually good marks also have been kept if you have some innovative ideas if to implement in your plant. So next is we'll just touch upon the energy efficiencies into the dairy plant. So what could be the, looking at the dairy plant design, if I want to achieve if I want to go towards this net zero or neutrality, so what could be the first thing that how can I arrest my energy usage? The first good thing somebody can say, just avoid the using it. So what exactly mean by avoiding? Basically the steps if which we can avoid into the dairy plant, then the energy saving is very good. For example, a CIP tank. CIP is you can say the giant which actually consumes the hot water, consumes the steam, the thermal energy. Also, there are some agitators, there are so many instrumentation is available. So it consumes the electricity also. The roughly we can say that if 150 1.5 lakh liter silo is there, and there is an agitator of 1.1 kilowatts, just based on the energy consumption, there is a data available that around 70,000 rupees per annum, it's just the cost of the electricity consumed for the agitation of this tank. For CIP, thermal energy consumed is more used than that. So while designing itself, if we can avoid and optimize number of tanks, number of lines, number of silos, then it's the best practice itself in a dairy plant. To the perspective of dairy plant,
I'll just add one more thing. See, the design part, suppose engineering has already done and given installed, that is, taking care of कि आपका जो layout है, flexibility of motion, operation, that all will be taken care of. होता क्या है कई बार कि ठीक है ये उन्होंने दे दिया and there is an automation done, calibration के हिसाब से जो भी chemical dose हो जाएगा वो अपना एक process चलता रहेगा. We as operational point of view, the man on the floor, we have to take care कि क्या उसका जो केमिकल उसमें डोज हो रहा है, एसिड या लाई, वो उस कंसंट्रेशन पे है या नहीं है. अब बोला आपको 70 डिग्री पे आपको एसिड 1% पे करना है, 0.8% पे करना है, तो वो आपको इंश्योर करना पड़ेगा. एंड इट इज नॉट कि नहीं वो कैलिब्रेशन कह रहा हूँ, जो आपका इंस्ट्रूमेंट सेंस कर रहा है उसके हिसाब से ऑटोमेटेड प्लांट में होता रहता है. You need to calibrate the instrument from time to time. उसमें स्केलिंग ना हो गया हो, प्रॉपर ऑपरेट कर रहा है कि नहीं, टेक सैंपल्स, मूव अराउंड द प्लांट, ये हमको करना पड़ेगा. सो अप्रोच जो है बेसिकली ऑप्टिमाइजेशन की है, वो ऑटोमेशन डेफिनेटली इट हेल्प्स, बट एट द सेम पॉइंट ऑफ टाइम जस्ट एन इनपुट कि यू एज अ ह्यूमन बीइंग ओवर देयर एन ऑपरेशनल मैन नीड टू लुक इनटू दिस एस्पेक्ट. दूसरा, अब टेम्परेचर ठीक है, 70 डिग्री अगर मिनिमम तो 80 कर देते हैं, 90 कर देते हैं, क्या फर्क पड़ता है. केमिकल ज्यादा डोज कर देते हैं. दीज आर ऑल वेस्टेज एक्चुअली. दिस कैन इंक्रीज योर कॉस्ट ऑफ ऑपरेशन एंड दैट इज अल्टीमेटली गेटिंग लोडेड ऑन टू योर पर लीटर प्रोसेसिंग कॉस्ट, डिसाइडिंग योर ऑफ कोर्स द प्रॉफिट एंड ऑफ कोर्स द मार्केट में आप किस तरह compete कर पाओगे. So this is the optimization part. Then you see the recovery. Basically पहले क्या होता था, टैंकर आया, उसको वॉश किया, जो अंदर फैट या एसएनएफ जो होता था वो सब ड्रेन हो जाता था. नाउ टू प्रॉब्लम्स यूज्ड टू हैव. द फैट एसएनएफ जो आपका स्टिक कर गया है टैंकर में, या उसको आप रिकवर नहीं करते हो, तो वो जाता है आपके ईटीबी में, और वो वहां पे ईटीबी का लोड बढ़ा देता है. ठीक है, देयर यू हैव टू गिव मोर अग्रेसिव काइंड ऑफ अ ट्रीटमेंट, बिकॉज वाटर स्टैंडर्ड्स बिफोर डिस्पोजल, यू नो, पॉल्यूशन कंट्रोल बोर्ड मॉनिटर्स दैट आल्सो. अब तो ऑनलाइन आ गए हैं. सो एक तो वो इशू है. दूसरा ये है कि जो फैट एसएनएफ है, टीएस आपका लूज हो रहा, पर केजी वो आपका बीच जा रहा है. सो यू रिकवर दिस by gentle flushing and taking this into a rinse milk recovery. Similarly, when your production is over, rinse all the water push is given through and pasteurized water, RO or anything. तो वो आपका rinse milk में जाता है, that you take it into your raw milk and process it again. So you will be seeing, if you calculate, हमको लगता है बहुत minor 0.5 TS recovery में क्या हो जाएगा, but it makes a lot of difference when you are dealing with lakhs of liter and hundreds of tankers together. Okay, this is your recovery. And yeah, please continue.
Yes. And adding to this, all these three aspects, as explained, that avoid, if we cannot avoid, we need to optimize. And after optimization also, we need to recover it back at to the best possible level. All these three are conventional approach. And the advanced these days approach is, if all three are there, and if those are not working, then just switch. Switch means switch to a non-fossil fuel energy. Just we discussed that some solar interventions were there, which were practically implemented and found very useful for our new generation dairy plants. So this is actually, I like this slide. This is how to improve and optimize my plant efficiency. You know, if anything I want to improve, or anything I want to know that whether it is healthy or not, it's in good condition or not. See, suppose if you go to the doctor and if you say that I'm feeling very uneasy, or I'm just restless, so doctor may say, "ठीक है बेटा, थोड़ा we will check your blood pressure, we will measure your blood pressure." Means the first thing what he will do, that he will measure something. So if I want to know whether my plant is in healthy condition or not, then I first apply the good methodologies for measurement. Measure at everywhere. Inlet of water, outlet of water, what is coming out, how much energy I'm consuming, how much electricity I'm consuming, how much steam I'm consuming. Just measure and measure and measure. After measuring, what will we do? If we have a good ample of data set in my hand for my plant, then just benchmark it. Qualify. And quality and qualitative and quantitative benchmarking has to be done for that. And after benchmarking with some contemporary plants and some good energy efficient plant, then what we need to implement is, we need to have some implementation into the place. And if we found that if there is a baseline and if our plant is above the baseline, then just maintain it. If we found that it's below baseline, then again have some implementation into the place. And the best thing that at the end, after this improvement, again, this cycle doesn't end here. Again, we need to measure. It's like a feedback control loop. And again, it's keep on till we achieve the complete, what you can say, the optimized and efficient plant, our model.
Thank you so much, sir, for your time. And it was a very wonderful presentation which we had right now. There are a lot of things in this presentation. I think there are means participant might have noted down some of the things like why to automate, and if we automate, what are the things it happens means benefit it give to an organization and to the plant, and various solar intervention you told about, and the best thing which you told about your favorite slide, like improve and optimize plant efficiency. Thanks you all for being with us and throughout this presentation. And I would like to give thanks to Sunil Sinha sir for taking out his time and coming over here and sharing his vast experience. And Shri Alak Kulkarni also, sir, he came over here, and with his diverse experience, he also shared many things from the slides. So thank you, sir, and thank you all.
Thank you.
We'll meet soon.